Hello everyone and welcome to another video. Now today we are starting congruence, this idea of congruence and specifically congruent figures. Now what do I mean by figures? I just mean a shape, a diagram, anything like that. Within the context of this video where let's take this to just mean shapes. We are looking at congruent shapes. And now everything we've been looking at in terms of these transformations, our rotations, our translations, our reflections, these have all been building us up to the idea of congruent figures. Now, the definition of these is that congruent figures are identical in every way. Now, think back to when we looked at our different transformations, for example. So take a shape like this, maybe let's do that a bit nicer. A trapezium, for example. Let's say we reflected this along this particular line here. And so let's actually also just label the points of my trapezium here. So let's call this A, let's call this B, let's call this C, let's call this D. If I were to reflect this, you can pause the video if you'd like and have a go at it on your own if you want to practice a little bit. But if I were to reflect this, then this would look something like this. And my new vertices, my pointy bits here, would get a different name. So this would become B prime, this would become A prime, this would become C prime, this would become D prime. Now, think of the two shapes I've drawn here. This is where this build-up thing I talked about happens. Consider this shape and this shape. These, although they're drawn in different orientations, we have transformed this shape to get the one on my right. These are still identical in every way. Now, what do I mean by identical? Well, I can make one from the other, and they're going to have the exact same dimensions and area within. So they're going to fill up the same amount of space here and here. So these figures are identical. And when we transform something, remember before in the previous videos, I talked about this idea of an isometric transformation. And I said that this was the idea of an exact same shape. So transforming something without changing any of the lengths of the sides or the area that the shapes make up. The reason that we've isometrically transformed these, and what we get by doing that, when we replicate and we'll duplicate one shape like this one on the left and transform it into this one on the right, we get two identical shapes. Because if I change the orientation back of this one, if I re-reflect it, it'll sit perfectly on top of this one here. It is the exact same shape. Now, whether we, reflect this or whether we, for example, rotate this. So let's say we have this same shape here, this one, here, here, and here. Whether I rotate this to look like this one here, whoops, what am I doing? If I draw it like this, that's roughly the same. Even though I have rotated this one in the clockwise direction, these are still isometric shapes. These are isometric transformations. In changing one of my shapes, I'm just changing its orientation. The lengths of the sides, for example, these are preserved. The area within it, this here, that is preserved. That's exactly the same as here. So these types of things we've done here are what we call congruent figures. When we have two shapes that are identical in size, we call those congruent. They are identical in every way. And our transformations have kind of built us up to this without us realizing it. Now, all different types of shapes, whether these are triangles, trapeziums, if they are congruent, they have the same dimensions, their sides correspond to one another. Now, take these two identical triangles. Now, I'm going to draw this one here. And this is identical because I have, I'm going to draw these and we're going to assume that they're identical. And they have these angles here. And if I were to draw another one here, this one here with sides F, D, E, I have what we call two congruent shapes. So up here, these are two congruent shapes. Okay, now we want to practice now this idea of finding what we call corresponding parts of the figures. So which part, for example, from this image, so for example, this point C, what is the equivalent point on the matching congruent shape? So let's do a couple of exercises of matching these up. Now, what makes this so hard to identify so far? Well, these are harder to see because they're not in the exact same orientation, right? They're slightly offset. And as a little exercise for you, what do you think has been done? What makes this shape, for example, different to this one? Or how can I make this shape, how can I alter it to make it the same as my first one? Well, to me, this looks like a rotation, right? I have taken my triangle here and I've slightly tilted it to the left. And I can see that because my right angle, for example, these two angles are equal. And that looks like it's been tilted slightly. This angle, which is equal to this one, and I know that because the symbols are the same. That one, you can see the point, this vertex C has been tilted a little bit to make E. So I can pick off these types of these elements of both of my triangles. So I can make a couple of notes here about which different parts correspond to others. So I can say, for example, and you can pick out a few extra ones if you'd want, if you like, but for example, vertex C corresponds to vertex E. What I mean by that is that this pointy bit in my left-handed triangle, C, the equivalent one, the one that is it but on a different triangle, is the one E here. And we can see that just by the orientation of the triangles and how the triangles look. Let's make another observation. I can say that the side AB, so this side here, let's do that in another color, side AB, well, that corresponds to, this is just the side next to the right angle and this closed black dot. So that's going to be this side on my second figure, on my second shape. So I can say side AB corresponds to side FD. And it's customary when we start looking at these further that the order in which we write these matters. So for example, I started with A, the one at the corner where the right angle is. So this one here, I've started with that. And I finished with B, the pointy end where this closed black dot is. So that is this one here. And they correspond to F first, which is in the same position as A, and D, which is in the same position as B. So we write those in order FD. It's just showing that we understand, when we do our working especially, which part corresponds to which. And we can make one more here, for example. We can say that angle B, well, what angle does that correspond to in my triangle on the right-hand side? Well, we're just looking for the same angle with the black closed dot, and that is going to be angle D. So we can say angle B corresponds to angle D. And these are just some little things we can note by how I've labeled this, and we're just matching sides and angles here. Now, these two are what we call congruent triangles. And when we say something is congruent, we write what we call a congruence statement. And this basically is just a concluding statement. You'll see this a lot more in later years when we start writing proofs. This is a concluding statement to say the triangle on the left is identical to the triangle on the right. And we write this, for example, by going, okay, triangle ABC. And we do this type of weird equal sign. This means is congruent to, which means exactly the same. We have to separate this from equations. So we draw this different type of symbol. This tells us that something is congruent, so identical to, and that is identical to the triangle FDE. And you can see I've written this. Let's try that again. I've written this with the correct corresponding sides. So the corresponding side to A, the vertex to A is F. You can hopefully see that here. The corresponding vertex to B, we said before, is C. Oh, sorry, is D. And the corresponding vertex to C is E. You can see that up here as well. Now, this particular thing here means is congruent to. So when I've written this out, I'm saying triangle ABC, by writing this symbol in here, I'm saying is congruent to triangle FDE. Now, we are going to try one more question in which we're going to look at a slightly trickier shape. We're going to look at a weird quadrilateral that I'm going to do. And this is a question to do with naming, just getting used to naming corresponding pairs. So when we're given a part of one shape or figure, we want to find the same one on the other figure. So we want to name the following congruent pairs for these two quadrilaterals. Now, this is going to look a little bit messy. I'll try to make these as close to identical looking as I can. But this question is going to be a little harder because the orientation is going to be a bit different. You can see it's going to be a little trickier to work with. And these I have G, let's call that G, H, F, and E. So we want to see, well, how have I made one of these from the other? Now, some of you may be able to see, hopefully, that I can actually make this one here out of my one on the left. There's a little bit of reflection happening where I'm mirroring this a couple of times to get one in the direction of the other. So I can make some initial observations. I can say, well, this shorter side is these two correspond to one another. And in saying that, I can answer, for example, our first question. So I want to say, we're naming the parts that correspond to A, vertex C. Now, vertex C is this one down the bottom here. And this is near, it looks like an obtuse angle. So which one out of these two looks like it has the obtuse angle? Well, G here is going to be the one in question. So vertex C corresponds to vertex G from my other quadrilateral. Now, the next thing is I want to find the side that corresponds to AB. So AB is this one here. So this is the longer side, it looks like, of my quadrilateral. So I can, just by eyeballing it, I can find the longest side on my other one. And now, apologies, I haven't drawn this too nicely in order to find this, but let's just consider some little hints that we can find, which are going to help us with finding the corresponding side. Now, my B here, we said corresponds to H, and the side A is just the one going away from B that attaches to make the straight line. And that's going to be my side E here. So I can say that for B, if I want to find the side corresponding to side AB, well, that's going to be side EH. Now remember, we said E corresponds to A and H corresponds to B. So writing it in the same orientation, that's going to be side EH. The E is going to come first because it corresponds to the A. And that is going to wrap up our talk on congruence. Now, we're going to talk about this a lot more in the next video, and we will get into looking at congruence in terms of triangles. Now, congruent figures, to sum up, these are just figures that are identical in the same way. And to make one from the other, they always undergo what we call our transformations from our last few videos. In all of our examples, you could see that one was made from the other by either a reflection, a rotation, or a translation. And in doing these, we preserve these transformations. We preserve our area, all of our sides, everything. So we get the exact same shape, the exact same figure. So now all we have to do is we know about these things, these transformations, so we can apply that to find corresponding sides of congruent shapes. Thank you so much for joining me in this video. I will see you in the next one.